Hi, this is lesson 231 on conditions for triangle similarity. Now, the previous lesson we talked about similarity and what that was, setting up proportions, um, and solving for missing measurements. Well, we're going to do a little bit of that on this lesson, but this is going to tie a little bit more to our congruency theorems that we saw before. So at the top of the notes I have, this is the same thing that I had on the previous notes. When I just wanted to remind you that when two polygons are similar, polygons could be triangles, all pairs of corresponding sides are proportional and all pairs of corresponding angles are congruent. All right, so key words here that you really need to get out of this is sides are proportional and angles are congruent. And know that those are not the same thing. All right, so proportional, remember that's when we set those fractions equal to each other in our proportions. Congruent means that they are equal measurements. All right, so now for when two polygons are similar, this is a lot of information. All the pairs, key here is all pairs of sides are proportional. All pairs of angles are congruent. That's actually a lot of information that we're getting when we know shapes are similar. But do we need to know all that stuff if we're going to prove that the triangles are similar? So the statement above is assuming we already know they're similar. But what if we want to prove that they are? Do we have to prove that all the sides are the same or all the sides are proportional? Do we have to show that all the angles are congruent? That would be a lot of work. All right, so the short answer is no, we don't need to do all that. So here's a reminder of our triangle congruency theorems. There were 5 congruency theorems that we used to prove triangles are congruent, meaning all the sides were the same and all the angles were the same. But similar triangles don't require as much. Right? So that was our triangle congruency theorems. Remember side, side, side congruency, side angle, side congruency, etc. All right. So the nice part is this list is going to get a little bit shorter for similarity. So let's look at those. So I'm just going to kind of give you the similarity conditions, and then we'll look at solving maybe some problems. All right. So the first one is actually kind of the same as our congruency. There's still a side, side, side. Except you'll notice now we're not using congruency symbol, we're using the similarity symbol so that I know it's different. And the main difference is that when we look at two triangles and trying to see if they're similar, in this situation we're looking at all the side measurements. So you'll notice I've labeled all the side measurements. Now what's true about triangles that are similar is all corresponding sides are proportional, right? That was part of the definition that I gave you at the top. All corresponding sides are proportional. So if we could just prove that, that would be enough for us to say that the triangles are congruent. We don't even have to know anything about the angles in this case. So that's nice. So what that means, keep in mind, we're not looking for them to be congruent, we're looking for them to be proportional. Right? And don't forget, proportional means that their ratios are the same. So let me just kind of remind you of that. So you'll notice I'm looking at A and D as being corresponding, and I'm going to write a ratio of those, A over D. And then I'm going to look at the bottom, B and E. Those are corresponding because they're in the same location. And so I'm going to make a fraction out of those, B over E. And then I could do the same thing with the last pair of corresponding sides, C and F. And I'm going to make a fraction out of those. So what I'm looking to see is, do all 3 of those fractions equal each other? If they do, then these triangles are similar. If one of them doesn't work, then they're not similar. So you have to have all 3 of those. All right, so that seems, if you're given all the sides, it's actually pretty easy. You just have to see if those fractions equal each other, and then you're done. And the second one, the second condition, also kind of taken from our congruency, is side angle side. And so it's very similar. We have two sides. Instead of worrying about all three, because maybe we don't have all three side measurements given to us, but we only have two side measurements. So in this case, I have these two. I have AB and I have DE, and I don't have the other side. So then I couldn't use side, side, side in that situation. But what we do have is an angle, and that angle, you'll notice, is right in between the two sides that are given, which is why it's side angle side. So side angle side, right? Side angle side. All right, what needs to be true here, same thing with side, 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 is we also need to compare the sides and see if they're proportional, right? Keyword there is proportional as well. And then when we check to see the corresponding angles, those need to be, the angles need to be congruent. All right, so I'm going to do angles are congruent, but the sides are proportional. All right, so you'll notice I have the ratios, and then I also have the angle. P and Q have to be equal to each other. They have to be congruent. All right, so if any of those is not true, if the sides ratios don't match, then it's not similar. Or if the angles don't match, then it's not similar. All right, so those are probably the two, those are the two conditions that are similar to the congruency, except we're just checking for proportions instead of congruent sides. The one that's a little bit different, it actually takes a few of the congruency ones and shrinks it into something even simpler. So this is probably the one that I like to use the most because it's the easiest. So you'll notice it only has two letters, AA, which means angle, angle. So if, assuming you don't have any sides given to you, imagine no measurements are given to you except the two angle measurements. That could be enough. All right, so the nice part is you just have to check to see, do those corresponding angles, right, are the angles congruent? That's all you have to check for. And so this is probably the easiest. Either they're equal to each other or they're not. You don't have to worry about sides. You don't have to worry about fractions. These are probably the best ones to try to use. So first thing I would recommend is when you're trying to prove triangles are similar, always check to see if you could do angle, angle. That's the easiest. And then probably the second easiest, I don't know, that's for you to decide. One of these, either one, they're kind of very similar. This one has an angle, so that could be easy as well. And then you only have to check two fractions. And so maybe side, side, side might be the one that takes the longest. So that's it. Those are the three similarity conditions. Unlike congruency has 5 of them, similarity only has 3. And I think they're a little bit easier to do as well. All right, so that's kind of in summary what you need to know. And so let's practice a couple of problems to see if we could kind of use some of that knowledge. All right, so in this problem, I haven't worked it out yet. I'll work it out with you. So this is actually problem 69 from the book. And so we're going to see if we could determine if these two triangles are similar. And here's a hint. Sometimes we need to use other skills to gain more information. All right, so, and what I mean by that is if I actually look at these, if I'm trying to prove these two triangles are similar, then what similarity condition might I use? Am I thinking of using side, side, side similarity, side, side similarity, or angle, angle similarity? Those are our three choices. So which one makes sense for us? Well, you go down the list and you think, okay, well, do I have all the sides? Well, I don't have any sides. None of the sides are given to us. So right away, I'm going to jump to maybe angle. Angle, is that a possibility? Because all I have is angles. So that would be perfect. And so then I start to look at the angles and say, okay, cool, I have an 87, I have an 87. Those match up. But then I look at the other angles, 25 and 65, and that tells me something's wrong, right? So possibly these angles, these triangles are not similar, right? So, but if you remember something, like I mentioned earlier, you might need to use some other skills to gain more information. And the more information that I'm talking about is this other angle. All right, so there's something you should remember about all the angles in a triangle, right? All the angles in the triangle should add up to, if I take 25, 87 in this angle, they should add up to 180 degrees. All right, so let's use that to see, just to confirm that we don't have another angle that might be equal. All right, so I'm going to zoom into this. And so let's say I'm trying to figure out this angle. So what I do know is this missing angle, I guess we'll call it, I'm going to use the letter x just so we could write an equation. So x plus 68 plus 87 should equal to 180 degrees. That's what I do know. So if I solve this equation, right, if I actually add those numbers together, so 68 plus 87 gives us 155. And so if I take that away from 180, that means x is going to equal to 25. All right, so then that means, let me highlight this, x equals 25, that's this angle. All right, so this is 25. Now, when I look at the other triangle, I notice there's a 25 in there. So then that means I have 87, 87, and I have 25 and 25. All right. So if we do the same thing on the other triangle, what do you imagine is going to happen? All right? If I take, if I want to figure out this angle, if I do, I'll just use the e. E plus 25 plus 87 equals to 180 as well. Now we're looking at e plus, what is that, 112 equals to 180. So that, if we subtract that, it gives us 68. So now we know this is 68, and we also know this is 25, which makes perfect sense. So if two of the angles are the same, the third one has to be the same. So that's why we have angle-angle similarity, because there's no need to have all three angles. We just need to check two of the angles. So we're just trying to see if these triangles are the same. They are the same. So I'm going to label these. I'm going to say triangle HIJ is similar to triangle. Now we have to match up the letters. So I started with H, which is 68. So 68 is E. And so I'm going to go EFG. So I'm going to go EFG. All right, and why are they similar? By angle-angle similarity. All right, so we just proved that those two triangles are similar, and all we check to see is if we had two matching angle pairs. All right, in this case, we do. We had, just to remind you, we have the 87, And we could use any of the angles. I'll highlight 68 and 68. All right, both of those work. We could also use a 25. It doesn't matter as long as you have two. All right, and so that's pretty much it. I'm going to go over some of these next problems. There's 4 of them. I want you to try these if you can, and then let me know if you need help with them. The first one is very similar to the problem we just did, so you probably want to do that. Again, show your work. If you're doing any kind of calculations, you need to show it, and then try to write a conditional statement. So the goal is to end up with, something like that. I was trying to do a box, but that's fine. All right, so your goal is to end up with something like that, or to say that they're not similar. All right, so I highlighted these to kind of help you out. On the second one, make sure you are trying to set up proportions here. And when I go over the last one, it'll make more sense. So we're trying to use corresponding sides. So I've highlighted them the same color so you know which ones are corresponding. And then on C, you do have a triangle within a triangle. We've kind of seen this before in a previous example. So see, this one's a little bit tricky. I'm going to see who could get it, who can't. Let me know if you want help with that one. And then the last one I actually want to talk about. This is an example of a side. All right, so all the sides are given. I've highlighted all the corresponding ones. So the way you should probably always think of this is the biggest sides always match up with the biggest sides. So in this case, 211.2 should correspond with the biggest side on the smaller triangle. So the biggest one over here is 58.8. Same thing with the smallest side. The small sides should match up. All right, that's really what you need to know. The bigger sides match up with the big sides. The small sides match up with the small sides. And what I've done is I set this up for us. And so what I'm trying to figure out is, do all these equal each other? So I set up proportions, 211.2 over 58.5, and I did the same for all 3 pairs. Right, the smallest one was 90 and 18. Now at first they don't look like they're the same, and sometimes they don't look like it at all. The pictures look kind of similar, so it's possible. So I would try to reduce the fraction. In this case, because there's decimals, the easiest thing for me to do was to put that in a calculator. 211.2 divided by 58.5, and I get 3.61. And then I did the same for the rest. And you'll notice all of these give us different measurements. So this is why we need to check. And so this is an example of you showing your work. And so that will tell me that you understand what a proportion is. It tells me you know what you're checking for as soon as I see this work. Yes, it's possible to do it all in a calculator, but if you do, then you're going to be losing a lot of points just because you're not showing me this. And so because none of these match, then these are technically not equal to, right? And so we would say these are not similar. All right, so these triangles are not similar. Triangles are not similar. All right, all the rest of these will be. And so I think, yeah, the rest of these will be. It's just about checking to see if you could show your work on these. Let me know if you want me to go over them. And I could do that with you. Or if you just want to check your answers, I could post those as well. Alrighty, that's it for this lesson.